Hello, my name is Vahid and I welcome you to a video lecture on the debate topic Ireland should aim to power all its electricity on wind, solar and water energy. As you know, man-made climate change is one of the biggest threats humanity faces these days. To combat climate change, many countries, including Ireland, are planning to transition to a zero-emission energy system by 2050. And one of the key solutions is that to achieve zero carbon electricity grid. And many people argue that accelerated electrification, especially in transport and heating systems, is a prerequisite to achieve this goal. But the key question is how a zero carbon electricity system should be achieved. As you can see in this figure, it's an energy system and this area, as you can see, is the focus of our debate and where different here is where the different fuels and technologies are competing to generate zero carbon electricity, including different technologies, nuclear, fossil-based, coupled with carbon capture and storage, different types of renewables, and bio-based technologies linked to electricity grid, and then this grid distributes and transport electricity all around the country to meet the useful demand. So some people believe that 100% renewable electricity relying on wind, solar, and hydropower is the main solution, but the others take an opposite position and mainly highlight the intermittency and variability nature of the renewable energy sources and emphasize that a higher share of renewable energies will deteriorate the the reliability of the grid. To cope with this challenge, in fact, efficient energy storage options are suggested, but system that considers only energy storage as a source of flexibility tends to be very expensive. So they believe that 100% renewable wouldn't be feasible for the case of Ireland, and fossil fuels coupled with carbon capture or nuclear powers or bio-based should be a part of at least a solution to to increase the flexibility, and there are very important requirements that should be considered to improve the voltage and frequency regulation, reactive power regulation, active power reservation, congestion management, and optimization of grid losses. In the next slides, I'm going to discuss some important potentials and barriers for each technology faces. Here, I will introduce CO2 capture and storage technology. It includes 3 steps. First, CO2 capture by decarbonization of fossil fuels or separation from flue gases. Then CO2 transportation to the storage site, usually by pipeline. And finally, CO2 storage by injection of high pressure CO2 into geological formation, especially deep saline reservoirs and depleted oil and gas fields and unminable coal seams. In terms of technology status, as you may know, the vast majority are in the US and the European countries, but there are lots of developing and under planning sites in all around the world. So it can be a promising technologies maybe in the future. But what are the barriers and potentials of this technology? The higher investment costs, operation costs, and thus higher generation costs is one of the key issues. The need to demonstrate that geological storage is safe and permanent. The need for international regulatory frameworks maybe for multi-decades or for 100 years. We need to store, CO2 underneath the ground, and who is responsible, on an international or national basis. And social acceptance is another issue of developing this kind of technologies. In terms of their potentials and opportunities, many believe that for technology development and policy measures will stimulate private investments and will reduce the cost and the upfront cost and the operation cost. And in terms of safety, a natural process can be optimized in CCS by choosing the right places and procedures to store CO2, in fact. The next technology is nuclear power plants. Except for the availability of uranium and higher investment costs, there are at least three main issues. The first one is reactor safety, and these three main issues need to be overcome. Safety issue is one of the key challenges. Some nuclear accidents, such as the last one in the 2011 in Japan, reveals that even the strict standard in Japan couldn't prevent or avoid natural disasters. So the next issue is radioactive waste, especially high-level radioactive waste are the highly radioactive materials produced as a byproduct inside the nuclear reactors. They need to manage and store for 100 years. And last but not least, proliferation issues. There are different treaties, international commitments, and the governments must follow international rules, and this may delay their operations. On the other hand, there are some great potentials. Different types of nuclear power plants can operate for more than 5 decades. So it's a promising technology in terms of operation. And as you can see in this figure, the modern next nuclear generation reactors, the fourth generation, I mean, which are small and medium-sized reactors with a capacity of up to 500 to 600 megawatt, are being developed to meet the needs of small countries such as Ireland for multi-purpose applications such as cogeneration, water treatment, or desalination. Their commercial availability is expected beyond 2030, and these reactors are inherently safe, more flexible, lower complexity, and these issues reduce the investment costs and their operation cost as well. So as a result, they have the shorter construction time that make them a promising technology as well for the future. The next technology is solar power. The above figures shows concentrated solar power technologies. They need adequate direct sunlight and thus infeasible for the case of Ireland. But the below pictures are large scale and small scale solar PV that are currently applied in Ireland. In terms of barriers, we can say that limited capacity factors, higher electricity costs, and variability nature are the most important barriers. And in terms of their potential, I can say that sustainable business, jobs creation opportunities, and a least cost solution to private electricity for remote areas are the key potentials for this technology. The next one is wind turbines. Wind turbines have some great, are the most promising technology for the case of Ireland because Ireland has ideal wind speeds, significant experience in terms of operation and manufacturing some parts of the wind turbines, and a skilled workforce are the other potentials. And in terms of barriers, siting is the first issue. The site is the place where you need to locate the wind turbines on the land. Selecting an appropriate location can be challenging. It requires permits, contracts, community relationships, and negotiations that leads to increased cost for the project. In terms of transmission, the second barrier, the transmission is the infrastructure and power lines needed to control and move the electricity from the, I can say, from the area generated to its consumption. But since the wind are newcomers, then most transmission lines that exist nowadays was built to contain the existing power plants. So more specifically, we can say that the offshore technologies, developing offshore technologies, need higher investments for to develop transmission infrastructures, in fact. And the final barrier, as always, is intermittency nature of wind turbines. The next promising technology is hydropower. In terms of barriers, hydropower usually depends on rainfall in the upstream area, and reserve capacity may be needed to compensate for a period of low rainfall. This may increase the investment cost as well. Major hydropower issues include public acceptance, high initial investment costs, and long payback period, long approval and construction cycles, and long lead time to obtain or renew concession rights and grid connections. Other barriers, such as strict environmental standards for water management, can also hamper hydropower development. And in terms of potentials, there are various technological options, including dams with reservoirs, run-of-the-river plants, pump hydro storage technologies, and one priority is that development of cheaper technologies for small capacity and low head applications to enable the exploitations of small resources. And finally, the bio-based technologies are another promising one. But there are some barriers, including increasing competition between different markets that may increase the price of biomass, higher investment costs, higher operation costs, and finally higher generation costs. The requirements for water consumption and larger scale use of biomass for power generation may raise sustainability issues. But however, we have some great potentials such as ample wood resources, forestry, or agriculture residues in islands that may include biomass as a part of solution, at least for the case of Ireland. So another key issues in terms of developing 100% renewable electricity generation is developing infrastructure for power grids, in fact. This figure shows electricity supply system. Left-hand side is larger scale centralized grid connected power plants, and in the right-hand side there are small scale distributed generators. They are connected, these generators, they are connected to the distribution grid and produce electricity close to demand sites or directly connected to the end users. This may reduce the need for centralized power generation and high voltage transmission lines, as well as transmission and distribution costs. However, appropriate adaptation and control of the electricity system is needed to ensure the reliable operation of grid with higher share of variable renewables. And I can say that The integration of significant amount of variable renewables into a power grid requires significant transformation of the existing grids. So the existing networks have some requirements. They aim to allow for a bi-directional flow of energy, either top-down or bottom-up. I mean from generator to users and the vice versa. The second one is establish an efficient electricity demand and grid management in order to reduce peak loads, improve grid flexibility and security of supply. The third one is introducing a significant energy storage capacity to store electricity from variable renewable energy sources when they are available in excess of demand. Improve interconnection of grids at regional, national, and international level is the next, one requirement. And finally, introducing technologies and procedures to ensure proper grid operation, stability, and control, including frequency, voltage, power balance, in the presence of significant share of variable renewable energy sources are very important. Altogether, these transformations lead to a concept of so-called smart grids, which are intended to provide the power system with the necessary flexibility to balance supply and demand in the presence of higher share of variable renewable power capacity. Experience with the integration of very high, more than 50% at least, renewables share is available from application for small islands. And finally, this slide shows how our debate is organized. The proposition groups will argue that fossil fuels, nuclear and biomass have no place in Ireland's electricity generation mix, and just 100% electricity generation from wind, solar and hydropower will be enough and feasible for Ireland. And the second group, opposition groups, will argue that 100% renewable energy source is not feasible in Ireland. So fossil fuels coupled with carbon capture and storage, nuclear and bio-based power plants should be part of our solution. Thanks for your attention, and I hope that we have a great debate in our next meeting.